Hey, it's Simon again. We're back with another problem today, and this is an interesting little problem. We're trying to find now the intersection of two linked lists. So if you didn't watch my videos before this on linked lists, go ahead and do that because, yeah, they kind of tie into this a little bit. So here's the example problem. So these two lists end up linking at the node C1. So we have to return that node is what we need to do, and like for this one, we need to return the node with the value 2. So you're probably thinking, oh, how are we going to do that? Well, my approach is going to be find the difference in the lengths between these two nodes. So we're going to have to iterate over them all once. Let me know if there's a better way to do this time complexity wise, but this is my approach. So you're going to iterate through both of the lists separately, find their length, then subtract the difference, and then iterate that list upwards uh, equal to the distance, and then just iterate them together, and if they meet at a certain node, then return them. So I guess technically time complexity for this would be O of n squared, I believe, because technically, yeah, I don't know, because you're iterating over them both twice, so maybe it's just O of n, but it's just like a long O of n. Anyway, this is kind of going to be a long one, so let's get right into it. So first I'm going to check for input validation. So if either of the nodes is null, then we're just going to return null. And then otherwise, we're going to need to create two integers. I'm going to call them length 1 and length 2. And those are going to be equal to a function called getLength, which I'm about to write. Haven't written it yet. Pass in a list node to it. And then L2 is going to be getLength of head B. So let's write that function right now. This is going to be returning an integer to get the length. So we're going to pass in a list node. I'll just call it head. And then basically what we're going to want to do is create an int length and set that equal to 1 because we see here that the node is not null, so it has to be at least of length 1. And then while head.next, we want head.next, not head, because we don't want it to equal to null. We just want, because that doesn't count as 1. So while that's not equal to null, then head is equal to head.next, and length gets incremented. And then finally, we just return length. So it's going to do that for both of them. And then let's add on to here another integer, difference, which is going to be equal to L1 minus L2. So if the difference is positive, and we don't have to test for an edge case here. I mean, you can if you want, but because it doesn't need to do anything if it's 0. So if it's greater than 1, then we need to iterate difference times over this function. So while I is less than diff, I plus plus, and then all we need to do for this is just set head A equal to head A dot next that many times. And then else we need to do it the same thing. So if difference is negative, or 0 I guess, then we need to set it equal to the difference times -1. You're thinking, oh, why times -1? Well, that's because we get a negative result here. And if we get a negative result, then we know that head B is greater than head A, but we just want the absolute value of that. So that's why we multiply it by -1. And you're thinking, oh, well, it may not always be negative. Well, it has to be. So if head B is longer. So this will only iterate if difference is negative. So that's why we can just always multiply by -1. We don't need the absolute value function in the math module thing. So now we're just going to say while head A is not equal to null, or actually we're going to want and because it's not. I always get tripped up with that. And head B is not oops, not equal to, I'm having problems typing today. I'm really hungry. I shouldn't film these on an empty stomach, but I do. And while that is not equal to null, then if we got to check this before we increment them because they could be equal right off the bat. If head A is equal to head B, then we're going to return head A. We could return head B if you wanted. It doesn't matter. They're both the same thing. And then otherwise, then we're just going to iterate to the next node in the linked list. Bada bing, bada boom. Oh, and I guess if this loop breaks, we're going to need to return null, because that means that it's something like this case where they're different lengths, but they never intersect. So let's run this hoss. Alright, it worked for the first one. Let's see if it passes all the test cases. Oh, yep, the god of coding strikes again. Yeah. Alright, thanks for watching, you hosers.